Alright, hello everybody, hello. Okay. Hi everybody, hello. Not exactly what I wanted there, but okay. This here. This and this. Okay. Alright. We'll wait for a couple minutes here, and then we'll go ahead and get started. Hello, everyone. Hello, everyone. Get a few more people in here, and we should be okay. Do you need to show your work on every problem of the test? Yes. Yes, if necessary. I think I put it in such a way where I would say yes. Yeah, because I put like, yeah, I know I did that. Yeah. I would like to see your work for the exam there. Basically, work that would yes. Mm-hmm. You will need to show your work for the problems there. Yes. No problem. Have you started on the practice test and the regular test? Like I said, the practice test is pretty much the same. Holla back at you, Brianna. I hope you're doing good. Holla back, sister. All right. All right. So, gotta get started though. We gotta do that. Yeah. Yeah. Gotta do it. Yes. So, let me go ahead and describe here give me just a second here. Okay, let's get started today. Welcome back to Thursday, end of the week time today. So today, we're going to be starting off Chapter 2, but before we do that, let's go ahead and acknowledge the test here, which I announced last class. Okay, so for the exam here, uh, it is posted on my math lab. There's a practice exam that is worth bonus points. Again, I highly suggest you try the practice exam before you do the real exam. They're pretty much one and the same. So it'll give you a good idea about the test and the format and all those kind of things. Um, if you try the real test again, just to let you know, nice. Um, if you try the real test, you get 2 attempts. Uh, you got no. Um, No, you do not. You do not need to submit for practice test. That is just for you. Okay, that is just for you. Um, so only for the real test do you submit homework to me. Now I've opened up in the underneath the assignments tab in D2L. I've opened up the chapter 1 test work. Okay, so you're going to find that underneath assignments in D2L, and then you can upload your files there that show me the work for every problem that you encounter there for the test. Okay. So again, you'll get 2 attempts and everything like that. You'll need to finish that in one go. And again, that'll be available to you until the 22nd. 22nd at 11:59. There are 30 problems. So if you try the practice test there, you'll figure out that I put the exact number of problems on there. Okay, the exact formatting is what you're going to see for the real test. If you do the practice test, by the way, you will get bonus points. So there are bonus points on the table for that. Also, don't forget that homework there for chapter 1 will be due on that very same day. Okay. So that is what the test is all about. I put a few more details there underneath the announcements on the D2L page, so feel free to go ahead and take a look at that if I missed anything. But those are the major things that certainly are important for the test to know. I've also given you plenty of time of which to finish the test. I think I set it at like, I don't know, like 3.5 hours. So should be plenty of time to finish each question. Any other questions regarding the exam? Again, type no in the chat, or if you do have a question, please type your question in the chat. No? Okay. So, right, if again, if you came late here, again, if you want to find out more details regarding the test, I've posted in the announcements on D2L. Alright, the test has been, what's the best way to show your work? The way that I showed you how to do it via my lectures there, Eric. So again, just show me, how you would hand do it. Basically the same way I kind of showed you on there, or again, if you have a different way of doing it, that's fine. I'm going to look over everybody's work and I'll determine whether or not that's proper work for that problem. So again, the score on my math lab will not necessarily reflect what I'll go ahead and record, because I'm going to take a look at your work there. So that's the best way to show the work. I gotta see the process about how you arrived at your answer. All right. Well, I've got to move forward here because we got some work to do here today. We got to keep moving forward here with chapter 2. That's what we're going to be doing here today. We're going to get through the first couple sections here of chapter 2. All right, so that's what's on the docket here for today. Now, chapter 2 here, just letting you know, let's go ahead and preview chapter 2 as we did a little bit last time. Today, we're going to be talking about fractions. Okay, chapter 2 is all about fractions of some variety. All right, I know that fractions are not the funnest thing in the whole wide world, but fractions is what we are going to be doing here today. Now today we're going to be talking about the basics of fractions. So that's what's on the agenda today. We're going to take a look at the parts of a fraction in this section here, and proper improper fractions. We'll also look at that as well. Okay, so let's go ahead and take a look at this here. All right. Okay. First of all, let's just talk about fractions here. You've heard of fractions before, okay, even if you don't like them. Fractions or something. Fractions are basically a part of a whole, okay? So that's what a fraction is, right? If you talk about fraction, a fraction is a part of a whole. All right, so we have, say, a whole pizza, right? The classic example, we have a whole pizza, we take a slice, that's a fraction of the pizza. Okay, we have $100, we take out, 15 bucks, okay? That $15 is a fraction of the total of the $100 that we have. Okay, so on the basic, that's what it means in kind of layman's terms. Visually, what does a fraction look like? Well, let's take a look here at that. So if we look at, say, the shaded or unshaded portions here, let's look at some of these shaded, unshaded portions and see, just identify it via a picture here. Now, if we take a look at this first one, okay, simple picture here. Here again, we have 4 pieces, and 3 out of the 4 pieces are shaded, okay? And so our answer here for this would be pretty simply just if you want to find the shaded area is going to be 3/4. 3 out of the 4 are shaded. There you go. That's it. Okay, now there could be other things that could be taken into account. So let's look at number 2 here. All right, it says write the fraction for the shaded portion of this figure. Okay, so what would the fraction here in this case be for this particular example? What do you guys think? See, what would this fraction be for this shaded area here? Let's count it up here. So we got 1, 2, 3, 4, 5, 6, 7, and we got another row of 7, so that's 14 total boxes. How many of those boxes are shaded? Okay, very good. So the answer is 8. And Ola, you're correct. We're going to talk about that as well. So the answer is 8 out of 14 boxes are shaded. All right. And we're going to see later on, and Ola's already a little bit ahead there, but in any case, we're going to see later on that there's an equivalent fraction reducing it down. And we're going to see that that indeed is going to be equal to 4/7. So we'll see that in a later section here, but yes, 8 out of the 14 boxes are shaded. Hopefully that's not too bad. Okay, now let's take a look here at talking about the parts of a fraction. So as you can see here in the parts of a fraction, we have two parts, all right? So we have, in this case here, actually in every case I should say, the two parts of the fraction work like this. Obviously we have a top part of the fraction, we have the bottom part of the fraction, but we have formal names for each, which you've probably heard before. The top part here, aka, will be called the numerator. Bottom part here is the denominator. Okay. So numerator and denominator is the way it's going to be. Okay. Actually, I'll just cut that. So let's go ahead and put that in here. So we have the numerator and denominator here. No problem. All right. So just again, like you hear, of course, we say 4 over 7 or 8 over 14 or 3 over 4, right? So again, whatever number's on top here. So again, the numerator is the top number of the fraction, and the denominator is the bottom number of fraction. Okay. Now, having said that, we're going to be looking at two very specific definitions. Okay, so let's take a look at that here in this case. The first one here is what we call a proper fraction. Okay, so what is a proper fraction? So a proper fraction is when the numerator is, let's go back here. So if we take a look here, right, that's what we got there. Okay, so the numerator is less than the denominator. Okay. So the numerator is less than the denominator. That's going to be a proper fraction. Some examples of that specifically would be, say, 7 over 12. Okay, 6 over 11. Okay, so notice here, in this case, the numerator would be 7, but that's less than the 12 that's the denominator. Here, the numerator is 6, but that's less than the denominator of 11. All right, 9 over 26. Okay, sure. All right, just making stuff up. But again, if that number could be even 19 over 26. So as long as that numerator is less than the denominator, that will be a proper fraction. On the flip side, we have improper fractions. Okay, so what are improper fractions? Well, this means that the numerator is greater than or equal to the denominator. Now there is something in here you have to be a little careful about talking about this definition. So let's at least, I guess I can't shift that over. All right. In any case, let's look at some examples here. What examples can we have? Well, here's a good example. 19 over 2. Okay, so clearly the numerator is bigger than the denominator. All right, make that a bit bigger. Let's throw in another one. 3, let's like 3 over, yeah, this actually, that's a bad example. 6 over 5. Okay, this is still a improper fraction. Again, our numerator is 6, and that's bigger than our denominator, which is 5. But now here's the part where you need to be a little bit careful. The part you need to be a little bit careful here is that it says the numerator is greater than or equal to the denominator. So what does that mean? That means that we're going to have 4 over 4. That too would be an improper fraction. Although we're going to rewrite 4 over 4, we technically don't write this too often in terms of just a fraction, because this is 1, but still, the numerator is equal to that of the denominator, so it still qualifies as an improper fraction. Okay? So that's what we have here for, again, examples of improper fractions. Are there any questions about both of those? Hello, Paul. No. Okay. Hopefully that's straightforward there. So. Okay. Well, I'm going to go ahead and move forward then, if there are no questions. Okay. Let's take a look here at, let's take a good look here at, let's see here. All right, so I'll throw out a couple of these here really quick, and you guys tell me if it's proper or improper. Okay. So these aren't too bad. How about, no, I already did that one. How about 5/9? 5/9, proper or improper? Let's go ahead and type that out in the chat there. All right, proper. Okay, that's correct. It is a proper fraction. Nice. Let's do 3 over 3. Proper or improper? Okay, good. 5 over 3. Oh, careful there. 3 over 3 is going to be 5 over 3. 3 over 3 is going to be improper. Improper because the numerator is equal to the denominator. So that's actually in the improper category as opposed to the proper. Yeah, improper for 5 over 3. Totally agree. 100%. All right. That's not too hard. Again, fairly straightforward there. But when we've established, again, what the parts of a fraction are, so now we have a pretty good idea about what we're working with. And in the subsequent sections here, we're going to take a look on how to work with fractions here a little bit more. Oh, we may actually get through another couple sections. That'll put us in a good pace. All right. Okay, so to go along with fractions, or at least parts of a fraction, we're going to go ahead and talk about the next type of number here that we're going to be working with in this chapter. And so in section 2.2 here, we talk about mixed numbers. So we'll see a lot of mixed numbers here throughout this chapter in some shape or form. Okay, so it won't be like super hard. It'll just be a matter of, okay, oh, okay, let's see where we're going to use it, and we'll manipulate it the way we need to, depending on the circumstances. Okay, first of all, let's talk about what a mixed number is. And there's going to be a couple ways we're going to kind of attack some of these problems here, as you'll see later on in this chapter. All right, but first and foremost, let's put in section 2.2. Should be, well, I might as well put it on the next page. All right. Okay. So let's talk about mixed numbers. Okay, so mixed numbers are going to have two parts associated with it. All right, so let's talk about said two parts. All right, so the first part here about we got the, again, and what does a mixed number look like in general? A mixed number here in general is going to look like this. It has a big number here. Well, I'll just randomly throw out one. We'll call it 6. And then it has a fractional portion, so it has a whole number and a fractional portion to go with it. So let's say 3/5. Okay, so I randomly just chose this. There's no rhyme or reason. So let's say we have 6 and 3/5. So we have, again, let's talk about the parts here. So the parts here specifically, as you can see, is going to reflect first and foremost. So the 6 here is going to be our whole number. All right. 3 is again going to be the numerator. All right, of the fraction. All right, and 5 here will be our denominator of the fraction. All right, now that we have that, we can also equate here what 6 and 3/5 would be if we put it together into two places. So you can actually equate 6 and 3/5 is the same thing as this. It's going to be 6 plus 3/5. So if you want to kind of visualize it in your head, you take 6 plus 3/5 and you get the same exact expression that you have over here. So we'll just make this bigger here. So, there we go. So 6 and 3/5 and 6 plus 3/5 are the same exact thing. Now, are we going to necessarily see it as 6 plus 3/5? Yeah, we will. We will add stuff together later on in this chapter. So you're going to definitely see where we're going to apply that. We're not going to apply this right now because we just want to understand mixed numbers here at this stage. All right. Okay, let's go back to the handout here for a moment. Okay. Okay, so what we're going to do next here is we're going to go ahead and rewrite. We're going to rewrite a mixed number here in terms of an improper fraction. Okay, so one of the things that we're going to use very heavily with mixed numbers is to change to improper fractions and then change back from an improper fraction to a mixed number. So that's what's next here on this docket. So let's look here. We're going to have we'll actually underline that. Okay. All right. Okay. So we've now changed this. We're going to change mixed numbers here into improper fractions. Let's talk about the steps here about how to do that. First, we're going to take a look at our approach here from, say, just a general point of view. So let's say we have 3 letters here. I'm going to go ahead and make these 3 letters. We'll say A is going to be the big number, the whole number here. B will be our numerator, and C here will be our denominator. Okay, so we're changing this. Now, in order for us to change this into a fraction, here's what we're going to do. An improper fraction, I should say. We're going to first take our whole number here, and we're going to multiply it by C. Okay, so that's the first thing you'll do in the numerator. And then add it to B. Okay, that'll be it'll be the whole number times the denominator plus the numerator. And you're going to put that entirely over the denominator. Okay, so this is our general rule here. Go ahead and put this over here. Go. So this is our general rule here for our guy. All right. Now, obviously, with letters put into play, we're going to need to take a look at how to apply that with numbers in play. So letters are great, but that can be rather confusing. So we're going to just break it down one piece at a time, and we'll see what we're working with. All right, let's try the first one here. Okay, so I'll have the rule over here to the left, and we'll write a number here to the right. So okay, let's try 3 4/5. Okay, so 3 4/5. All right. So I'll go ahead and show this off here first. So I'm going to take my whole number here, which is 3. I'm going to multiply that by the denominator, which is 5. Okay, that's the little c part here, the denominator. I'm going to add it to the numerator here, which is 4. And I'm going to put that all over the denominator here of 5. So now all I have to do is figure out what the numerator is after multiplying and adding here. Okay, so we got 3 times 5, which is 15, and 15 plus 4, which is 19. And so if we do this together here, we get 19 over 5 would represent 3 4/5. Make that a bit bigger for you. Boop. All right. Okay, are there any questions about how I came up with that? I'm going to do a couple more examples here, but are there any questions so far about that? Okay. Nope. All right. Good stuff. All right. Sorry, got to slam down that shake. All right. uh, Protein. All right. Beefcake. All right. Let's go ahead and take a look at another one here. Okay. Let's try. Let's try 5 3/7. Okay. So I'll give you guys a try here. 5 3/7. So can anybody tell me what this would be as an improper fraction? 5 3/7. 5 3/7. 5 3/7. So, all right, 38 over 7. Okay, very good. That's correct. Let's go over why it's 38 over 7. Okay, so we're going to get here again 5. Again, we're doing 5 times 7. All right, so again, the whole number times the denominator plus the numerator. We'll put that over the denominator. So 5 times 7 is 35. 35 plus 3 is 38. And we get 38 over 7. That is correct. Good. So far, so good. Very nice. Okay. So you can see here, it's not too bad. Okay. Meant to go back to the thing here. All right, so it's not too bad. It's pretty straightforward in terms of what is expected. Okay. So really very, very simple, at least what we're going to be doing. Okay, so there's a few more examples here to show off an improper fraction. We'll go ahead and do one more here in regards to that. So let's go ahead and do this one out. Try 4 7/8. 4 7/8. I'll type that in the chat there. So 4 7/8 equals blank. Okay. So 4 7/8 equals what? What would 4 7/8 equal? All right. Very nice. That's correct. Okay. So 4 7/8 equals, again, 4 times 8. Okay. Well, actually, yeah. 4 times 8 plus 7, all over 8. Okay. So 39 over 8 is correct. Okay, so put that here as well. All right, so that's how we're able to get that 39 over 8 there. Okay, good stuff. All right. Okay. Are there any questions about that? Any questions at all? Nope. Okay. All right. Nope. All right. Great. Okay. Now we're going to go the other direction here. Okay. So what we're going to do is we're going to go from, we went from a mixed number here to an improper fraction. Now we need to go backwards. We need to go from an improper fraction to a mixed number. Okay. So we're going to discuss some of those here in this instance. So let's go back to our guy. All right. So we're going to change improper fractions to mixed numbers. Okay. So we're going to follow a pretty couple simple rules, but got to be diligent about it nonetheless. Okay. So let's talk about the steps here about how to do that. So really not too bad, but step one here is to divide both numbers from each other. So all you're going to do is just do regular division. Okay, nothing too fancy here. All right. Now, step 2 is to arrange the numbers you find in the following order to get your mixed number. Okay, so we're going to talk about that here. Okay, so how does it work? Well, whatever answer we get after dividing the quotient itself. All right, so let's say we want to say the quotient here. All right, the quotient here is going to be our whole number. That's the answer that we get up top there. Okay, the next part is going to be the remainder. This is with the remainder stuff that we talked about here. The remainder here will be our numerator. Okay, and the divisor here, whatever we divided by, will be the denominator. Okay, now you're probably saying, hang on a second, what does that mean? Those are just words. And I'd be like, okay, that's pretty fair. So we need to do an example here. We need to go ahead and do an example here. Yeah, thanks, Dark. Cool. That's why I have moderator like you. Yeah, the bots are bots. They're very annoying. We like classes with real people, not with bots. Anyway, so let's take a look at an example here. All right, so let's go back here for a second. Okay. Now let's take. Let's see. I know we did these, but I don't want to really go backwards with those. Okay. Let's go with 23 over 6. Okay, so let's go with 23 over 6, all right? And we want to convert that into a mixed number. So what we do here is we're going to do just regular old division here. So let's bring out the paint tool here. Okay. So this is what we have here. So we have 23 over 6. And we're just going to do straight up division. So we're going to put 6 on the outside, 23 on the inside. Okay. So nothing too fancy going on here, just exactly what we've done before. Okay, so let's answer some questions here. How many times does 6 go into 23? How many times does 6 go into 23? All right, 3 times. Great. That's right, Maricela. Okay, so the answer is 3. Now we know that 6 times 3 is 18. So we subtract that, and we get 5. If we do 23 minus 18, which is our remainder. Okay? So this is a pretty quick and easy problem, but it does get us our mixed number here. So let's look at what each part represents. The quotient is the whole number. The quotient is your answer that you get up here up top. This is your quotient. So this 3 here is going to be our whole number for our mixed number. Okay. Next is the remainder. The remainder here is 5. 5 here will be the numerator of our fraction. And then finally, the denominator of a fraction is the divisor. The divisor is the number we divided by. So that's going to be put right here. So our final result here, as you can see, is 3 5/6. Are there any questions about that? We're going to do a couple more examples for sure, but just making sure here. Well, actually, I could let you. Okay. Yeah, I think that's not a bad idea. All right. Okay, so now using this as a template here, let's use this as a template, this 3 5/6 that we have here, this example. Let's go to our notes here for just a second, and we're going to give a couple of these a try. So, which one? Yeah. Okay. Actually, yeah, we do have to talk about that too. Just thinking about some exceptions here. Okay. One other exception here would be just to talk about a couple other ones really quickly. Okay. Let's talk about special rules here when it comes to changing it over. First and foremost here, some special rules that are rather important. If you take a number here and you divide it by the same number, so let's say I have a over a, all right, this is going to equal 1. So if I have 3 in my numerator, 3 in my denominator, 3 over 3 is going to be 1, or 3 divided by 3 is 1. The second one is if I take a number a and I put that over 1, I just get that number back. So if I have 3 over 1, that's still 3, and that's how I would express my answer. So these are two special rules here that we follow, just depending on whatever is given to us. Okay, so these are ones that you can do really fast without having to do too much work, and there's justification for doing so. Okay, all right, so that's fine. I just wanted to state those rules here really quickly. Those guys are not too bad. We're going to come back and take a look at these, of course. Okay, so again, just as an example here, 3 over 3 is equal to 1. And what's another example here? Example here would be 5 over 1 equals 5. Okay, all right. All right, let's take a look here at this one right here. So I want you to take a minute or two, okay? I want you to try 78 over 7, all right? I want you to try 78 over 7. So let's take a minute or two. Let's have you try that. 78 over 7 as a mixed number, okay? Once you found your answer, go ahead and type it in the chat. Okay. Okay, we'll give it another minute or so. Then go ahead and type out your answer here. Ola's got one answer. See what else you guys get. Okay. Jonathan's got an answer there. Okay. Okay, we'll get 10 more seconds here. See if you guys got any other answers there. Alright, so let's take a look at 78 over 7, and let's see if it indeed equals exactly what was stated here in this instance. So let's go back to our little paint tool guy. Okay. So let's start off with 78 over 7. So we're just dividing here straight up. Put 7 and 78 here. So 7 goes into 7 one time. 1 times 7 is 7. Subtracting that, we get 0. Going to bring down the 8. 7 goes into 8 once. And 1 times 7 is again 7. With a remainder of 1. So what we get here is we have our 11, which is our, again, our quotient. So we're going to have that as our nice whole number there. Okay, so 11. And here we have a remainder of 1. That's going to be our numerator, 1, over our divisor, which is 7. So that is correct. 11 and 1/7 is spot on. Okay. All right. Are there any questions about mixed numbers there? No? Okay. Alrighty. Well, let's keep moving on then. That's perfectly fine. So let's keep moving on here. Okay, so that's pretty much the end of section 2 too. Okay, so section 2.2, again, also not a very long section, but again, one of those sections that we're going to be using, as this chapter continues to move along. Okay, so we're going to see answers that'll be expressed in mixed numbers. We'll see where we process it in terms of improper fractions. We're going to see that for operators especially, so we'll see that later on for sure. Okay, let's look at factors here, which is section 2.3. Now, I don't expect us to get through this whole section here today, but we're going to go ahead and get started here at the very least with how we can find factors of particular numbers, as again it will help us in a future sections here within this chapter. Okay, so just a lot of little tidbits of information, but they kind of split it up in a lot of different ways. So okay, so let's talk about what factors are first and foremost. Okay, we're going to find out what factors are, and then prime and composite numbers, we'll go ahead and describe that. So let's talk about factors of a number. Factors of a number, simply put, is factors of a number are numbers that divide the initial number, I guess I'll say cleanly. So meaning it divides it nice and even, alright, there's no decimals, no nothing. So that's basically kind of what I'm saying, cleanly. In this case, no decimals, no decimals. Okay, so if I take 6 divided by 3, we get a clean number of 2. Alright, so that's basically what a factor would be in that particular case. Alright. Now we're also going to have 2 more definitions here. Alright, so there's these 2 definitions are very important as well, as we'll set this up for other things. So we'll make an important note here. First of all, you may hear such things as prime factorization. So prime factorization means it's a number that only has 2 factors, meaning prime. So I should just say prime number, actually. That's probably better. It's a number that only has 2 factors, 1 and itself. Okay, so there is a note here. All numbers have 2 default factors of 1 and itself. Okay, so this is always true. Okay, all numbers have 2 default factors of 1 and itself. So if I wrote like 15, the first 2 factors should be 1 and 15. Okay, that's it. You should have 1 and 15 as your 2 possible factors there. Those are always defaulted to that. Composite number is basically a number that has factors, that has additional factors apart from 1 and itself. So just the it's basically it's 1 itself. So if let's go back to 15 here. Well, is that a composite number? The answer is yes. Alright, the reason why is we could take 3 times 5 and that would equal 15. So 3 and 5 would be factors of 15, for example. Okay, so we would call that a composite number there in that case. Okay. Alright, let's go ahead and take a look at factorizations of certain numbers. Let's take a look at 12. Okay, so let's take a look at 12 here. What are the factors of 12? What are the factors of 12? So the factors of 12, the first two factors of 12 are going to be 1 and 12. So you can take that to the bank. It's always going to be 1 and itself. Okay? Bring up this. That's right, Dark. The other factors here, what divides 12 cleanly? Well, 2 divides that cleanly. Okay? That's true. 2 times what is 12? Well, 6. That part's true. Alright, we're missing 1 there, Dark. Missing 1. Missing 1 other factor there. Yeah, we're just missing that 1 guy there. We're missing 3 and 4. Okay, yeah. So 1 times 12 is 12. 2 times 6 is 12, so 2 and 6 are good. And 3 times 4 is 12. So those are also factors there. So we could say for a certainty that 12 is a composite number here in this particular instance. Let's look at that next one there. Let's look at 60. Okay. Let's look at 60. Okay. So let's put down the first two. First two here right away, no matter what, is 1 and 60. So we can just go ahead and just skip those two since we know it's automatically in there. All right, what other factors of 60 do we have? Hmm. Okay. Very good. All right. Nice job, Ulla. Don't forget the 60 there at the end as well. Um, okay. So let's go over that for just a second. Okay. Let's say you're a little confused about. Oh, actually, we're missing a couple more there. Actually, Ulla, we're missing a couple more there, but we'll go over that too. But let's say you're a little confused. It's like saying, um, let's say you're confused. You're like, I don't know what the factors are. How do I go through that methodically in order to find those factors? Now, you could just go up starting from 1. Okay, so the next number up would be 2. And you would say, all right, does 2 divide 60 evenly? And you would say, yeah, it certainly does. Okay, what does it divide to? If I take 60 divided by 2, well, that would net me 30. Okay, so I could say 2 and 30 would be a pair of factors. And I could keep going down the line. I could try 3. I said, does 3 divide 60? Well, yes. 60 divided by 3 is 20. So again, I have another pair of factors here. Okay. I could try 4. 4 here, does 4 divide 60? You bet it does. What does 4 times what is 60? Well, if you try that out, that is 15. Okay, that's 2 as well, right? We could try 5, and we say, all right, does 5 divide by 60? Yes, it does. And 60 divided by 5 is 12. So notice I'm just going with pairs that would be, say, multiply to 60. That's how I'm just kind of breaking it down my factors here. Just these little pairs here. We're just going one number at a time. So let's say, okay, does 6 divide 60? Yes. Okay, that's 60 divided by 6 is 10. That's another pair. I try 7. 7 doesn't work with 60, so that's out. I try 8. Does 8 divide 60? No, unfortunately not. 8 does not divide 60. 9 divided by 60? Nope. You could try that out. you're going to end up with a decimal. That's not good for a factor. And then we finally get to 10, and notice 10 is already paired off with 6, so we're fine there. Okay, so we already have the same representation here, so everything else is pretty much taken care of. So you can pretty much at that point stop the process, since you're just going to repeat the same things. And that's your final answer here. You're going to get, in this case, 12 factors. And again, just pairing them off is very helpful there in this case. Okay. Any questions about that? Nope. All right. Hopefully that's pretty straightforward there. Okay. Let's take a look here, and let's go ahead and try some problems, some other examples out here. Okay, so this is going to be on page, which page is this on? This is page 80 on the notes here. It says, which of the following numbers are prime? Now remember what prime means. If we go back to our definition, a prime number means a number that only has two factors, 1 and itself. Okay, so there's no other factors outside of 1 and the initial number. Okay, that's what a prime number is. So let's take a look here. Is 2 a prime number? So pretty much a yes or no question here. Okay, the answer is yes. That is true. Okay. By the way, 2 is the only even prime number. Okay, so 2 is the only even prime number. The only two numbers that divide 2 are 1 and 2 itself, so that does qualify as a prime number. Let's look at 11. Is 11 a prime number? Okay, very good. 11 is a prime number, right? Only two numbers divide 11, and that's 1 and 11. You can try every other number in between, but unfortunately, it's no go. How about 27? 27, is that a prime number? No. Okay, why not? What divides 27 that's not 1 and 27? Three and 8. Well, 3, yes, but maybe not 8. I mean, it already disqualifies from being prime for 3, but yeah, okay, there we go. I was like, wait, what? 8? I was like, 24 maybe? Is that what you're thinking about? All right, 9, yeah. So 3 and 9 are also factors of 27. Uh, I'm like, okay. So those would make sure that this is 27 is not prime. Okay. All right. All right. So we got 3 numbers here, real quick. Which one of these numbers here are going to be composite? So we have 3 numbers here: 6, 11, and 25. Of these 3 numbers, which of these 3 numbers is composite? What is a composite number? Composite number is basically a number that has factors that are apart from 1 in itself. So what would be our 2? We would have which one of these 3 numbers, which of these are composite numbers? Thank you. That's really kind of you to say. "27 has more than 2 factors." Yes. Thanks, my friend. I'm sure if I were able to see you, I would probably say the same thing. Hey man, math class, it's lit. There you go. All right. I'm just trolling you guys. me and my me, me and my limited limited British slang. I'm just calling myself that. That's not you, my friend. Not you. I wasn't referring to you, so. All right, so which of these 3 numbers here are going to be composite? Of these 3 numbers here. The last one here. Now, respect to you. Didn't mean to disrespect you. That wasn't. Thank you, my friend. I appreciate the kind words. So the 2 numbers here that are composite would be 6 and 25. Okay. 6 and 25 would be our 2 numbers that are composite. And the reason why is that 6 can be broken down into 1, 6, 2, and 3. All right. Thank you, my friend. If you have questions, then please let me know. And 25 can be broken down into 1, 25, and 5, since 5 times 5 is 25. So that's why 6 and 25 are composite. 11 is a prime number, since only 1 and 11 divides 11 straight up. All right. Okay. Are there any questions about this example here? So, Yeah, more to go for that, so that's fine. All right. Okay. Any questions about what we kind of gone over here today from sections 2.1, 2.2, and this first half of 2.3? No? Okay. All right. So, as I'll say here, this is where I am going to stop in terms of the material here for today, since we're pretty much out of time. So for next time, we're going to resume right here for talking more about prime factorization. Whatnot, we'll do some factor trees as well. All right, so that's will be on the docket here, and then we'll move on to another couple sections after that. So hopefully we'll get done with this section here. This section's a little longer, so it has kind of like a lot of things. But we'll talk about lowest terms. Okay, so we'll talk about that. Homework is first and foremost here. Let's talk about what you should be keeping up with. So first and foremost, do the test. So chapter 1 test, and again, do the practice test before that. Chapter 1 test and any chapter 1 homework. Okay, and then if you have that done, then sections 2.1 and 2.2. Sections 2.1, 2.2, 2.3 would be to kind of keep up with the pace there. Okay, so sections, we'll finish up 2.3 here next week, but I want to just at least say, okay, if you want to kind of keep up with a little bit of material, you're not going to know the entirety of 2.3, but you'll know some of it. But your first priority is to get the chapter 1 test done, but do the practice test first. Again, that's bonus points on the table. All right, and they should be able to, that should be your priority at least for the weekend. Yes, that is all due on the 22nd. That is correct. Yes, it'll be due next Tuesday at 11:59 p.m. Central. Sections 2.1, 2.2, and 2.3 are not due that day, obviously. Those are due later on. Any other questions? You have a few questions that'll take. Yeah, Dark. Just go ahead and email me later if you have specific questions. So yeah, that's perfectly fine. Just go ahead and email me later, and I'll be happy to take your questions. No? Okay, no questions for today. Okay, if there are no questions here, I'm going to end off here. All right. So again, I want to wish everybody a very wonderful weekend. All right. If you do have questions, please email me because I obviously do have another class right after this. So, but yeah, feel free to email me. I'll be happy to answer you back via email. Maybe back for office hours. So, again, if you want to talk then, we can. In the meantime, for those of you who are for my 11 o'clock class, stick around. I'll be back in 15 minutes. For those of you who are in this 9:30 class, I wish you a wonderful weekend. Take care of yourself. Get that test done for Tuesday. All right. And again, enjoy. All right. I look forward to hearing from you next Tuesday. Yeah. All right. Have a great weekend, everybody. We will talk to you later. All right. Be back in 15 minutes if you're here for the 11 o'clock class. All right. Take care, everybody.